you want to take your pipette while it's tipped like that and put it on the high side and touch it down to the bottom, and then turn this upright and suck. That way, by having this down against the bottom, it keeps you from sucking up pieces of tissue into the pipette or sucking it onto the end of the pipette so that you can't suck anything else up because you've plugged the end of the pipette with your piece of tissue. So this makes things a lot easier if you just go in on a tilt and then turn backwards and suck it out. All right. Remember that these pipette tips, the longer these get, like when you use those long pasture pipettes, they have a lot of shear force in here. So if you're dealing with single cell plants, there's enough in here as you kind of badly suck up and down to basically rupture the cells. All right. So your timing. Timing is not so crucial on this because we're just doing kind of a general fixation. If you fix for an hour or 3 hours, it probably won't have a tremendously noticeable effect, although differences in your aldehyde concentrations and timing will cause an effect in your tissue. When you do freeze fracture is where you freeze your sample and then you keep it frozen and you hit it from the side with a razor blade, which then causes this to fracture, and it's going to fracture between if you're a fracture plane, your choice for where you're going to go through the cytoplasm is either through the cytoplasm, which is mostly water, or through something that's not as tightly held together as water, and that would be the lipid bilayer. And so when you come in, and the fracture is going to preferentially go between the bilayers and pop it open. And so what they discovered is that there were these nice crystalline looking array of vesicles near the synaptic cleft. And this lab was cranking out papers on it, and someone tried to reproduce it, and they couldn't do it, and they finally figured out that this was a fixation artifact, and that the longer you left it in the aldehyde, the more organized this array became. And so it really wasn't a nicely packed array in a specific transfer site for these vesicles. It was an artifact where they all ended up migrating through the lipid bilayer. Even though it was infixative, you were still getting some rearrangement of structure. So yes, it does make a difference how long you leave it. In terms of some of the things that we're looking at, it's probably not going to make a difference.
Dr. Barlow?
Yeah.
So are you going to have to make the rinse buffer, or should I make it?
You can go ahead and make it.
I'll figure it out.
Okay. Yeah, we'll need 3 times however many vials there are.
Yeah.
We'll need 3 times that, then some. All right. So you've had your samples in varying amounts of time. Remember, they first got hit with the aldehydes when you dropped them onto that Petri plate and started cutting them up. Is it going to matter between an hour and an hour and a half? Not going to matter for what we're doing. So you need to come in and do 3 rinses, and then you're going to put them into the osmium. And let's see, you haven't made up the osmium, correct?
No.
All right, so I guess I can crack an osmium. So how many ampules in there, Danny?
I'm at 18.
Should be 4 times covered.
18? So that's like 50 mLs. I mean, 54 samples times
18. Each person has 2 vials.
Did you get 20?
No.
It's 18. 162. What was that?
It's about 18.
10 equal ignorance too. There should be 20. There should be 21 samples.
Yeah, I don't know why there isn't the number that I was expecting.
There should be 21 samples.
Everybody did 2?
I did 2.
Yeah.
Yeah. 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there should be 21. Everybody did 2 samples.
There's some under the
Two
ice.
tubes each, right?
Everybody should have done 2 samples.
Oh, he did one. Oh, did 21.
Yeah, I did one.
How many do we have?
We've got 10 people.
We counted 18, I think, or 17.
Did someone not?
Oh, you did one?
I thought we were doing one each.
No, you're going to have
One
So-
with the
So
samples
that's
of
2
this.
missing then, right there.
Yeah, there'll be 2 samples in each pair, so each person should have 1 sample, and it should be a duplicate. So one of them is going to be with gadolinium and the other without.
Yeah.
So they can probably split theirs into.
Yeah. You did hard, right?
Did hard.
Yeah. So there's extra hard floating around. So
Should save some.
yeah, see how many you've got in there, and see if you can split them into two vials. Okay. So we're solved that one. All right. So let me show you what the ampules of aldehyde look like. I already pointed out, did I not, where the fixative refrigerator is? So down where you would keep your fruits and vegetables, one drawer holds the osmium, and the other one holds the glutaraldehyde and formaldehyde. And they come in different concentrations. I've got 8% in 10 ml aliquots. I've got 8% in 2 ml aliquots. And I have formaldehyde 10 mLs at 16%. I should have some 25% aldehyde, and so that should do it. So the 25% aldehyde would be something you might take when you're going out on the cruise. I gave a bunch of my 25% to those people, and then when they added the 25% to the seawater, it diluted down to 1%, so they only needed to add a very small amount in order to fix their cells to preserve them. So they didn't have to carry gallons of diluted aldehyde. So here are don't drop that. So that is crystalline osmium. It forms these nice yellow tissue. That's been around for a long time, so it doesn't look as pretty as it might. So this you would crack that open and add liquid to it. I also have some that's a gram in there. I also have a container that's only 1/10 of a gram that I would dissolve in 100% acetone or 100% methanol, and then I would put that at -80 and do my fixations as free substitutions at minus 80 degrees. And it dissolves almost instantly in methanol or ethanol or acetone. It doesn't dissolve that quickly in water, so you have to make it up ahead of time. Instead of that, we're going to use these ampules of it, which are sealed with nitrogen gas over the top. So these are from Electron Microscopy Sciences. They're pre-scored at the neck here. And I have a cracker. Is Rick back there?
Yeah, Dr. Bizarro.
Ask him to get the cracker.
What is that?
This
Yeah.
this is a glass ampule.
Oh, no, what it was in it.
Osmium,
Oh,
4% liquid.
Oh, liquid. Oh.
Exactly.
Now, Electron Microscopy Sciences is a nice company. They're over in Philadelphia on the East Coast. The other company that's commonly used for their supplies would be Ted Pella. EMS has this nicely labeled. It's got their name, it's got their address, it's got the chemical in it, it's got the concentration and the percentage, the volume and the concentration. Ted Pella doesn't always put that down. And looking at this glass ampule, brown ampule with very little written on it, you don't know what it is. So you want to be careful when you sort of grab these out that you make sure that they're labeled, or that you label them so you know what it is you're cracking open. Although these are pre-scored, in theory you could just wrap a paper towel, and I know people that just wrap a paper towel and then they just bend it and it breaks. I've done it where even in the cracker here, it breaks, but not quite the way they intended. It doesn't just crack at the score mark, the whole top shattered, because this was heated up to seal it. And so in that case, you've got little glass fragments to worry about. And so if you're not careful, if that gets into your block, when you try to cut that, it's going to ruin your glass knife, not to mention ruining your diamond. All right, so to use this, and the size of the ampule isn't so important because I've got smaller ampules like this one I'm passing around. You could crack this in here. You just have to be careful to get it in, and you're just going to put it in here. You want to tap it to make sure you get all the liquid out of the top, and then you're just going to kind of put your fingers there and bend. No, it didn't shatter. All right. Rick, you want to put this in the hood? I don't want to leave this out. It's cracked open, so leave it upright. Thomas can transfer that into a well, or you can just take it out and put it in an ice bucket. Here's an ice bucket.
As soon as you crack it, it starts to
yeah. But since I kept the two pieces together, it would come out a little more slowly than if you just opened it up and waved it around. I've smelled osmium. I told you I'm well preserved. And it's kind of like getting a hit of bleach. You kind of get this irritation in your throat. And I've also frosted my corneas one time when someone put it on a hot plate and it wasn't in the hood. And I came by and I could smell it. And so for a couple of days afterwards, I had halos around all the streetlights and things until the cells sloughed off over time. I don't recommend it. Don't recommend it. In the hood, it should be safe. As I say, you want to wear protective clothing so that and coverings so that you don't turn your hands black and whatnot. It has been used. Everything work okay?
Yes.
Good.
Burning your hands.
Right. You don't want to get it on your hands. It has been used, as I mentioned. It was a cure or treatment for some cases of arthritis and things. So it's not, and you don't want to try to commit suicide by drinking the stuff because it doesn't penetrate very well. And so all you'll do is just kind of kill some of the uppermost layers of things as it goes down and whatnot, and make you extremely uncomfortable. You know, jump in front of the trolley. But not the 5 o'clock, the 5:15 out of college, please, because I want to get home. I don't want them to have to shut down the whole system. Okay. All right, so are we ready to start some of the transfers?
We need another 10 minutes or so.
Another 10 minutes or so. Okay. So 3, let's see, it's 10 to 3, it's 10 to 4, 1. Yeah, but the class is only supposed to go to 4, right?
Well, we were prepared to stay here till 5 or 6, right?
Well, I don't know if everybody wants to stay here.
Just that was the email that I sent out. I don't mean to speak for everyone. Speak for yourself, man. Sorry.
So we can, if they've been in, let's see, so they went in like 1:30, 2:30. So they've been in fixative for like an hour or so.
Yeah.
So we could go ahead and start the rinses because we have to move it along. So if your blocks are small, it shouldn't be a problem. If not, then you're going to have some problems. In that case, you would want to trim your blocks not to get into the center of the tissue, but stay towards the outside. So, all right, now for Monday, remember it says on your sheets that you can either come. I don't care how you split it up, but I don't want any one person to generously volunteer to transfer all of the solutions, all of the steps for all of the people. So you're going to let it soak in like 2 mLs of gadolinium. Yeah, but we've got to make that 1 ml of gadolinium for like an hour or 2, and then just give it a quick rinse with water. And there should be a gadolinium waste bottle, so that put your waste into the gadolinium waste bottle. And then from that point, everybody can be together. So if you want to, if one of your crew is going to come in to do the gadolinium for an hour, then you could come in at an hour later and then just start doing the alcohols. And so we'll do 50, 75, 95, 100 in alcohol, and then into acetone 2 or 3 times. And then from there it's going to go into a 1-to-1 mix. I'm sorry, 2 parts acetone to 1 part plastic. And so if you get in early in the morning on Monday, you'll have your dehydration done by about 1 in the afternoon, including that gadolinium step. Leave it all afternoon in that mixture, the 2-to-1 acetone EPON. Sometime in the early evening or later evening, depending on how you want to set your schedule. It's not critical. Transfer it into a 1-to-2, so it's 66% plastic, and let it sit the rest of the night into the morning, the next morning, at which point you'll come in and transfer it into 100% and let it sit all day on the rotor. And then in late afternoon, you want to come in and you have to be able to transfer your samples into the blocks. And for that, I'd like everybody to be here at least for part of the time when I'm around or Thomas is around, so that we can show you how to put you have to make little tabs, so you'll go into Word and type out, say, the tissue that you're working with, say liver, and then copy and paste it in a row. And you can if you put liver 1 and then copy and paste it in a row, and then you can make the date, copy and paste that in the second row, and then copy those 2, and then copy and paste a couple more, and then you can do find and replace to replace liver with spleen or root.
Excel.
Well, if you do it in Excel, then you have to you want when you're done with your label, you don't want lots of space in between them. Because you're going to have this and maybe some number, and then you're going to have the date. And so if you have a lot of space here, then for each one of these, you're going to have to cut this out, and then you're going to have to cut this out. Whereas if you do it with just a space between them, then you'll cut with your scissors and cut along here, come with your scissors and cut along here, and then you'll cut this one off, and then you'll cut this one off, that one off, that one. So there's only the 3 cuts, and you want to don't put a space between this one and the next tissue underneath it, so that if you're careful with your scissors, you can just cut it into these little strips, and then you can leave yourself, don't cut these short, leave this attached to the paper so that you can grab hold here and then go snip, 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 rather than trying to hold onto the little end here. Ask me how I know all these things. You can set this all up, and I usually do it in 8-point and then I tell it and try to use a font that's like Geneva or Helvetica, things that don't have little curlicues. I forget what they're called on the letters, the scripts. And then print out at 50% reduction. And yes, I know you could go in and set it for 4-point and whatnot, but it's impossible to see anything at that point. So put this up in a reasonable size that you can read, then set it up for 8-point, and that is large enough for you to be able to see. Sometimes when you do that, the spacing gets a little kerfluey, so you'll have to go in and space it so everything forms in these squares. You can have space on either end if one line is shorter or longer than the other, but they all have to go into this mold. So everybody's going to get a mold like this. This one happens to be double-ended. This one isn't. It doesn't matter. You want to put one tissue in each end. And that's not because they're necessarily going to be more useful, because as you know, once you've got a nicely trimmed block, as long as you keep that upended nicely, you can carry it around and whatnot. When you've got double-ended trimmed blocks, then it becomes a real pain, because how can you put it down on anything? So putting the tissue in both ends is merely an easy way to supply yourself with extra tissue without having to have an entire new set of blocks. So if you have a row of 7 here, you can have 14 samples. So if you have to, you could actually even saw it in half and super glue it onto another blank block. So there are ways to not go crazy but still have plenty of sample, because once you throw away your vials and whatnot, that's it. All you've got is what's left of their mounts. So that would be it. So you're going to have in the, as you know from the blocks that you've been working with, you're going to have a mold a block that might look like this. You'd have hopefully tissue up here and tissue down here, and somewhere in the middle you're going to have your label. You want to make sure you put a label in there, because as you know, these things just look like little blocks of black. And so you're not going to be able to tell what something is. Alright, so those are some of the different tricks and easy ways to lay these out. As I say, I'm a big fan of find and replace. And so you can replace the numbers, you can then go in and replace the tissue without having to type each line and copy and paste it to make a bunch of them. Alright, so you can start doing your rinses. Once we get them when we get into the osmium, I'll show you how we make up plastic.